Okay, so let's see. So if there's one carbon, then what would be the prefix?
Mentos?
Mentos? Meth?
Methane.
Meth. Okay.
Sorry.
Not Mentos. Somebody's thinking about the experiment already, huh?
Yeah.
If there's two carbons,
That's my mistake.
F.
F. Okay. 3 carbons.
Prop.
Prop. 4
Prop.
carbons.
Bute.
Bute. 5 carbons.
Pent.
6 carbons.
Hex.
Hex.
7 carbons.
Hept.
8 carbons.
Oct.
9 carbons.
On, I believe.
10 carbons.
Is it deck? Decane?
Yep. 11 carbons.
Undeck.
12 carbons.
Duodeck?
Dodeck. Duodeck.
Right, dodeck.
Guess that's a good way of remembering it. Okay, so pretty simple so far.
Sure.
Okay, so good. Now I'm gonna throw some signs up. Chemical structures. I want you to tell me what they are. I hate this. Every time they update, screw stuff up. Okay, that's the first one. Okay, so these are the 4. So what would this guy be called?
Well, it's an alkane.
Okay, so that's the family it belongs to.
Yeah.
Okay, so what would be the name?
Pentane.
Pentane.
Okay, so we count the carbons just to be sure. So that's 1, that's 2, that's 3, that's 4, and that's 5. Okay, what about this guy?
7 heptene.
So it has 7 carbons. 1, 2, 3. So would it be 7 or would it be 1 heptene? Remember the rule, you always want to go with the shortest numbering system. So I can go either way.
Yeah, so 1.
Good answer though. 1, 2, 3, 4, 5. And there's 8 carbons.
So it's octane and it's an alkene.
Okay. So to be precise, it would be 1, octene, and you said it belongs to the alkene family. Okay, so this brings us up to the distinction, right? If we look at both of these guys, you count the carbons here, 1, 2, 3, 4, 5, 6, 7, 8. It also has 8 carbons. Now, if we just named it octene and octene, are they the same? Are the double bonds located in the same place?
No.
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 And they're going to behave differently depending on who they're going to react with, right? So we need a way of distinguishing between those. And the way that you do that is finding the lowest number, right? The lowest, sorry, let me explain this again. The functional group that you're looking at needs to be at the lowest number it could be at. So the one that has the highest priority needs to be at the lowest number that it can be at, okay? So in this case, we only have a double bond. So that's the only functional group that we're looking at. So we need to count the carbons and find the way that gives me the lowest number. So 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4. Guess it's 4 either way, huh? 5, 6, 7. So in this case, it doesn't make a difference which way we go because it's 4. The smallest number will be 4 either way. Okay, but like up here, if we went the other way, that's 1, 2, 3, 4, 5, 6, 7, 8. So in this case, if we chose 7, that would give us a high number compared to the 1. So this guy here is also an alkene, but the way we would name it would be 4, because you put the double bond where it starts at, so it's 4 octene. Okay, do you guys see that?
Yes.
Questions, concerns, Cash? Let's see who's there. Who's in my house? Anissa, are you there?
Yeah, I am. Sorry.
Okay. So, do you see it?
I stepped away for a second. What was it on this one? Which one are we looking at? The third one?
Yeah, the second and the third one, how they differ from each other. Count the
Yeah, so
carbons,
we're
they
just
have the
trying to
same-
find, we're trying to find whichever way we start from, what is the smallest, that's going to give us the smallest number, right?
That is correct.
So it'll be starting from the left.
Yep. Okay. Piece of cake. So then you can help me with this one that's below it, right?
Yeah, so that one will still be 3. And then there's 1, 2, 3, 4, 5, 6, 7, 8. It's still going to be the oct.
Okay.
And then it's going to be, there's a triple bond. So it's going to be double bond, single, double, at least one. I forget what the triple bond was.
Somebody want to help her out with the triple bond? What is
It's
the
the alkynes.
so it's an alkyne. So then what is the suffix I would use for the
So
after
it'd
the
be
al?
heptine or
Heptine.
octine, I'm sorry.
You mean octine? Okay.
Yeah.
So 3-octine.
So if we're ever showing you this, do you want us to count from the back way as well, or just like go with the one that we know is the shortest?
Go with the one that you know is the shortest,
Okay.
because there'll be some tricks that I'll throw at you, kind of keep you honest. So, but
Yeah.
okay, questions. Concerns? Catch. Okay, you guys ready for some complexity? Yeah, no, maybe?
Yes.
Yes.
Okay, so let's say, we'll take this first one. Let's say we add side carbon chains. Okay, so when we're adding our side carbon chains, you get, again, you want to find, well, first off, you want to find the largest or the longest chain that you can make. So you want to count to figure out which one is going to be the longest. This happens, the green happens still to be the longest, right? So if we count 1, 2, 3, 4, 5, right? And if we start here, 1, 2, 3, 4, 5. So I could use this chain here, or I could use this chain here, which would also have a weird thing coming off the side of it, right? Or if I started here, that's 1, 2, 3, 4, 5, right? So we want to try to find the one that has the longest chain, and that would be the easiest to write, right? So if I use this chain, 1, 2, 3, 4, 5, being my longest chain, on this side of the chain, we have a single carbon left, because that's just one, although it looks like it's kinked. Let me fix that. Okay, so it's just a single carbon, so it's one carbon. So one carbons begin with what? There's only one carbon.
Meth.
Meth. Now, since it's a side chain, what we're going to do is add to that meth YL, making it a methyl. We also needed to say where it's located at. So it's going to be located at on the second carbon. So then we call it, it'd be 2-methyl. Okay. Now on the third carbon, the chain that's coming off of it has how many carbons?
Two.
It has 2. 1, 2. So then that's going to be which prefix?
F.
Can be F. So it's on the third carbon. We call it 3F, meth. And then we use the longest chain that we have, which is the pentane. Okay. You guys see that?
Yeah.
Yes.
Pretty simple, not too hard.
Maybe another example or two.
Okay. So let's give you guys another example. Okay. So the first step is to do what?
Count how many carbons?
Count the carbon. So first we need to find the longest chain. That's going to be your first step. So what is going to be the longest chain? If I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yes.
If I start here, 1, 2, 3, 4. So we know that one is going to be shorter than the other one already. Right? And if I went the other way, it definitely would be shorter. So we know that that isn't the longest chain. So the blue isn't the longest chain. So I would say, looking at it, green is the longest chain. Would you agree?
Yes.
Yeah.
Or we could get a comparable chain with this guy. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Same.
Yeah, that's the one that I counted.
Yeah. So either one could have given me the same, right? So I could have started here. It could have been my 1 in that case. Okay, so I could use either one. Okay, so what is going to be the longest chain carbon called? What are we going to call that? Since there's 9. Non. So nonane.
Yes.
Okay, so our longest chain is going to be at the end of the thing, and it's going to have the A and E, or the E and E, or the Y and E. It's going to have whatever the major functional group is at the end, okay? And then, what's coming off that second carbon?
Another carbon?
So how many?
1.
1. Okay, so then that guy's going to be called what?
Methane.
Okay, so we have a methane. So we call it, would we call it methane, or would we call it, oops. Since it's a side chain,
You add the YL.
we have the YL. So we call it methyl, right? Okay, and it's located at the second carbon, right? So we put a 2. Now, if I look on the fourth carbon, what's there? Or I'm sorry, that would be the 5th carbon. What's at the 5th carbon?
Other methyl.
Another methane or methyl.
Methyl, okay? So
Methyl.
the way I would do that is I put 5, and then I'd say di methyl, because then that accounts for this one and this one, and it tells me where both of them are located at. Now, what about on the 4th carbon? What's on the 4th carbon?
2 of them.
There's 2 of them. So then what would that guy be called?
Ethyl.
And we need to say where it's located. So we'd call it
4.
so 4-ethyl, 2,5-dimethyl, no name. Piece of cake?
Kind of.
And the stuff in front, it goes by alphabetical order based upon the functional group it is. So if it's di, if it's tri, if it's that, you typically ignore it. You just use the methyl. So it would be ethyl, methyl, and then like propyl. Okay. So let's see. You want to try one more? Or do you guys got it?
No.
One more.
Can we...
No, another one.
One more.
How do you take a topic that I actually understand and make it something that I don't understand?
What do you mean?
This was going to be easy, and it's not easy.
It is easy.
It was.
Piece of cake. It's only going to get easier.
So for the side chains, they're gonna be called methyl. While
Yes.
the YL.
Yeah, so if it has one carbon, you're going to add the YL. If it has, well, YL to the meth. So instead of putting the A and E, right, it's only one carbon side chain. So this is only one carbon. This guy's also only one carbon on the side chain. So those guys are going to be methyl, right? This guy has two carbons. It's going to be ethyl.
Oh, okay.
If it was a butyl, if it was four carbons, then we put butyl, right?
Okay. So it's the YL that we're adding.
Yeah, so the YL to tell me, you're letting me know that the side chains, the YL lets me know that it's a side chain and it's a single bond. It's not a double bond, okay?
Okay.
And it's a YL single bond side chain. That's what you're letting me know.
And for the test, will you be docking points? Because you said that it's like in alphabetical order, like the ethyl, methyl.
Yeah, I'll give you guys a break on the alphabetical order part of it because you guys are in 2A,
Okay.
but at some point you're going to be taking organic chemistry, so you need to get in the habit of doing that.
Okay.
Okay.
Thank you.
You guys think you're getting out of it, but you're going to find out that a lot of the articulations for your nursing courses are going to require you to take 2B. So, because a lot of them are moving in that direction. Okay, are you guys ready for the next one? Another shot, one more?
Ready.
Okay, let's see. Make it a little challenging because Mandy is telling me it's too easy. Isn't that right, Mandy?
She's a beauty.
Okay. Okay, so let's find the longest chain. Where should I start counting? Let's try here. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8.
And
Sorry.
again, I counted a different route and still got 8.
1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's 8, 8. Okay, so here's a dilemma, right? So what do you guys think we should do? We could have a double bond in the side chain, or we could have a double bond on the main chain. Now, in terms of hierarchy, who's more important?
The double bond would be in the main chain.
The double bond is going to be in the main chain. That's correct, because it has priority over the single bond. So we're going to use this route here, the purple route. Okay, so knowing that, what am I going to name this guy, this beast?
Octene.
Okay. Okay, octene is going to be at the end. Okay, where are the side chains and what are they?
There's a methyl, an ethyl. Would it be a propyl? Oh, there's two methyls and I guess a propyl.
Okay, so we have two methyls. So how would we do that? How we handled our methyls?
Dimethyl.
Okay. How do we handle our double bond? Where it's located at?
What was that?
How are we handling our double bond? The location of our double bond?
Don't you go from where it starts?
Okay. So then I should put a 2 in front of it.
2. Yeah.
Okay. So and then these dimethyls, they're located where?
2 and 4.
2 and 4.
Okay. And you say we have a propyl.
At 4.
Okay, so 4 propyl. And then you say we had an ethyl.
Yes, at 5.
Okay. Piece of cake?
Yep.
Giselle. Giselle will be honest with me. Piece of cake,
Yes.
girl? You got it?
Yeah, I got it.
Melissa?
Yeah, I got it.
Okay. Sam? Samantha? Whitney?
Yeah, I got it. I'm watching.
Z?
I got it.
Okay, good. Okay, so shall we make it a little more challenging?
No.
What do you mean by no? This is too easy, right? You're like, piece of cake. That's what I'm hearing. Okay, so let me clear some room. Let me introduce you to another functional group. So this is the generic way of saying hydrocarbon. R represents the hydrocarbon. This represents your functional group, OH. So these guys, this family is called the alcohol family. And I like talking about this one first because I like to drink alcohol. Okay, so this guy here would be called, now let me help you out. This here, this bond represents the bond between the oxygen and the carbon, and it's understood that there's a bond between the OH, but we just write it out this way for simplicity. And this is called, by the way, this is called a carbon skeleton, right? Because we're using the skeleton, we're not using all of the components that are there, okay? So this will be your first carbon, this will be your second carbon, and this is your third carbon. So what do you guys think this guy is going to be called?
Vodka.
No, it's not vodka. How many carbons?
3.
3 carbons.
Be
Okay, so then
but-
prop.
And then I have no clue what the OH is going to add.
So it's prop. And then is it any, do you see any double bonds there? Are they all
No.
single bonds?
They're all single.
Single.
So then AN And then the alcohol adds an OL. Propanol. You've heard of propanol before, right? Isopropanol.
Maybe sounds kind of familiar.
Rubbing alcohol.
Oh yeah.
Isopropanol. So this guy's called 1-propanol because it's on the first carbon. The alcohol is on that first carbon. Okay. Isopropanol is actually 2. It's 2-propanol. And often we'll call it iso because you can look on both sides, you have a carbon on each side of it, right? Of that middle carbon. So this guy is called isopropanol, or
Yeah, the ISO sounds more familiar.
okay.
That's what I see more on the bottles of rubbing alcohol.
Yep. So in the old days, they would call it isopropanol. Now, since you're using this nomenclature for you guys, for the record, because you'll be seeing it, IUPAC nomenclature. Okay, so this is IUPAC organic chemistry nomenclature. Okay. So let's see. What if I have this guy? What is this guy called? Anyone? Anyone?
Pentanol? Hexanol.
Okay. So, but where's the OH? Is it at the 1 or is it at the, where's it
3.
located? So you have to give me the
3.
location. Okay. So is that the shortest distance?
Yes.
Okay. So then it would be 3.
3-hexanol.
That's right. Okay. Piece of cake. So what happens if it's a double bond or a triple bond? Let's say I have a triple bond here.
Well, if that happens, I don't know what to call it.
Well, let me show you. So you have to tell me where the alcohol is. The alcohol's priority over the triple bond and a double bond, and I'll start adding your priority list here in a second. We know it's a Y, so there's 2 ways of doing it. One way is to put the YNE into the nomenclature and you tell me where it's located at. This one is located on that first carbon, so you'd go 1, which looks horrible, right? Or you can put it up front and let me know that it's 1. Let me do it like this. Oh, I guess it would be. No, actually, this would be the only way to do it. If I do it the other way, it'd be incorrect. So. Okay. Piece of cake.
Sure.
So why is it YN instead of YNE? Like, do you just throw away the E?
The E is being, since there's an E, you don't put the E, you put the OL. The OL is going to take its place. Just like when we talked about propanol. Propa doesn't it end with an E normally? We just drop that E and we just put an OL.
Okay.
Okay?
The one is for the triple bond?
Yep. It tells me where the triple bond is at.
Okay.
So since this guy would be for the main group, whatever we're talking about, so that tells me where the alcohol is at. Sorry, there is another way that I could have written it. I could have written it as where I could put that in the location of that next to where it is as well. So like I said, hexane 1 YN, oops, 3 all. So I could have wrote those either way. Okay, questions? Okay, so those are your alcohols.
Yes, who decided to name stuff like this?
So there's a committee, right? And you have to be voted in to sit there and sit on the committee. And so they decided to sit there and decide a common nomenclature, because what was happening was people were naming things after themselves. Oh, we'll call this Grant's reagent, or we'll call this Michael's reagent. But then people start rediscovering the same chemicals, and so you have Michael's and Grant's reagent, which are exactly the same thing. And so you're thinking you order Michael's reagent, and you're getting Tyler's reagent or something like that. So there wasn't a clear distinction between it. So a committee got together and said, okay, we need to get this organized, because otherwise we're just going to have all of these chemicals named after these people, and then they're going to be renaming chemicals over and over again. So they got together and they said, okay, so this is the system that we're going to agree on. And it makes sense some of the time, and then some of the time you're like, I don't get it, you know? I don't understand why that's a priority, like the triple bond over the double bond. To me, it makes sense to have the triple bond on top, but you know, this is what they decided to go with. So, and it's what the community as a whole have agreed to. And it makes it easier to order chemicals compared to the way that we used to have to order chemicals.
The people on that committee are worse than the people who decided to add the Greek alphabet to math.
And chemistry, right? We haven't gotten rid of it here either. So, okay, so let's talk about, so far we've talked about, let's see, low man on the totem pole was who? Who's low man on our priority list? Who's lowest at the bottom? Anyone?
The carbons.
The hydrocarbons? Which one?
The single bond.
Single bond. Good job. Then who's next?
The triple bond, the hydro.
That's right, triple bond. So that's the
Alkyne.
alkyne. Okay. And then who's next?
The double, the in. Alkene.
Alkene. Okay, so then alcohol comes before them. And actually, let me do this. I know that there's going to be a few more between that. So, questions on the alcohols? Are you feeling comfortable with them? You want to try one more before we move on?
Yes.
Oh, I forgot one more thing. I don't know if I went over it. So we have these guys, which also belongs to the alkane or alkene or alkyne family, depending on if it's a double bond or a single bond. These are kind of special. So how many carbons does this guy have?
Six.
Okay, so what would this guy be called? Or what do you think it'll be called?
Hexanol or hexane?
Hexane.
So it'd be hexane,
All right, there's no,
but
oh wait,
it's a ring structure.
it's
Right?
closed.
They all connected, it's closed. So we call this guy cyclohexane. You guys see that? I mean,
A lot better name than the last one.
okay. So what would this guy be called?
Cyclobutane.
Cyclobutane. Unstable, but it'll exist for a little bit.
So it's
This
like a
guy?
really short half-life or what?
Yeah.
Cyclopentane.
Okay, piece of cake.
Yes.
Yes.
Okay, so let's make it a little more complicated. So now what is it called?
Cyclopentanol?
That's right.
Kind of, no? Maybe?
Yeah, no, you're right. Cyclopentanol. But to be exact, you would say 1 cyclopentanol. Because that tells me that I have an OH on that first carbon. And the first carbon is always going to be defined by that functional group. So it kind of works out perfectly, right? So if I have this, what do you think I'm going to call that? Roman, what are you thinking? What's hanging out right here?
I don't know.
How many carbons is that?
3, 1, 2.
There's this line
Oh,
is
there's
3
one.
carbons. It's 1, right?
No.
So then that would be called what normally?
Meth.
So meth, and then because it's a side chain, what do we put it on side chains? Anybody want to help him out?
The YL?
The YL. Okay, so then if this is 1, this is 2, 3, or if I go the other way, 1, 2, 3, 4, which way do you think I want to go?
3.
3. So then it would be, oops. Three methyl cyclopentanol. And you see, the guy who has the highest priority, they get their last name, right? Kind of like the way we have our civilization. You know, my wife is going to get my last name because I have a higher priority, right? I like that. Nobody's disagreeing. This is a perfect day. Wow. Either that or everybody's asleep, one or the other. I'm not going to get any comments at all on that comment.
Dr. Henry, we would hyphen.
We would hyphen. Okay. Finally. Okay, so you guys ready for the next one, right? So we have alcohols under control.
Sure.
We turned up already. Oh, by the way, drinking alcohol. You never want to drink methanol. Methanol is horrible. It makes you go blind. You get hairy palms.
The name sounds poisonous.
It is. It's horrible for you. You want to drink ethanol. So it looks like that. 2 carbons. OH. Okay. So that's drinking alcohol. Somebody said vodka. That's what vodka is. Right. Or actually, almost all alcohol is OH. The difference is where it comes from. and the flavor. Okay, questions, concerns, Cash?
No.
Okay.
No.
The next group that we're going to be talking about let's see, how should I do this? Let's do ethers. Ethers. So the generic now on the priority scale, it's kind of weird. They're considered to be low on the priority scale, but when we do the nomenclature, we always put ether at the end, right? So this represents one hydrocarbon, this represents another hydrocarbon. So if I go, let me give you a concrete example. So if I go like this, 1, 2, 1. Okay, how many carbons do I have over here on this side of the oxygen?
1.
1. Okay. And then on the other side, how many carbons do I have on the other side of the oxygen?
2.
2.
1, 2. Okay, so this guy would be called ethyl, methyl, ether. Okay, so if I have, let's see, we're talking about ethers now. So we have this guy. What do you think that guy is called?
Dimethyl. Dimethyl.
Methyl ether. Okay, what about this guy? Okay, this guy would be called let's see, Melissa.
Pentyl.
We'll ask Melissa. Melissa,
Okay.
Yes.
okay, what would this guy be called?
Would it be a pencil? Because there's 5 on one side and then there's 5 on both sides.
Is there 5 on both sides?
So there's 5 on this side and then 1. Oh, never mind. There's 4. It's because I started with
Okay. So we have pentyl on
Pen-
one side. So
and
then the other side would be
Buntle.
butyl.
Oh, beautiful.
That's all right. I know it looks like butt, so you want to say butyl, right? So butyl, pentyl, and then the ending?
The ending would be ether.
That's right. Oops, I spelled that right. Okay, piece of cake?
Yeah.
Is there like a list anywhere of these things, like lined up, I guess, like ether, all that kind of thing, and definitions anywheres on the internet?
Chapter 13. And then I also have a little slide for you, but it doesn't show you the figures. There's also, I have one that has the figures, but I have to find out where I put it.
Okay.
The copy. So I have one for you guys that it's a really nice one, if I can find it. And I'll be uploading that for you as well.
Okay.
Although you can't use it for the exam, you got to remember the structure, right? I want you to be able to recognize them. Okay, so O's, right? So if it's just an oxygen and it has a hydrocarbon on both sides, those guys are going to be ethers. So on the priority table, technically ethers are here, technically. Although if there's a double bond and a triple bond and all of that stuff, they actually do start falling into the other categories. So, okay, let's see, ethers, on the ethers. Oops. Okay, so I'm going to give you another one. Okay, so if you have, we'll put X, R, where X represents a halide. What are halides? And this is going to be your hydrocarbons. What are halides? What are halogens? Let's see. Jacqueline E.
Yeah.
What is a halogen or a halide?
I don't know.
Jacqueline L.
Something on the periodic table though, right?
What about on the periodic table?
It's something.
I like that. It is something on the periodic table. So what is it on the periodic table? What group are they located at?
I don't know.
Jacqueline L.
7.
Main group 7?
Yeah.
Main group 7. Okay, so which is group 17. Okay,
Yeah.
so they're the halogens. The halogens, which is fluorine, chlorine, bromine, iodine. Remember those guys? Yeah, no, maybe. You should, because they're very important. Okay, so when you guys have, this guy's called an alkaline halide. And on our periodic, here we go. Alkaline halide. I spilled coffee on my keyboard the other day, and now it's sticking. So when I type, letters aren't showing up. I have to press really hard. Okay, so alkylide halides. So these guys have a halide on them, right? And the way that we address that, they're lowest man on the totem pole. They're even below the alkanes. So we just tell where they're located at, and we put an O at the end, and we drop I and E. So in the case of bromine, it's bromo. So we'd say, in this case, 2-bromo. And then our longest chain, 1, 2, 3, 4, 5. So what is that, 5-carbon chain, Mandy? Is that making your life miserable?
Yeah, sure.
5-carbon chain is going to be called?
Pen something? I don't
Okay.
know. I'm just gonna have
All
to read
single
my
bonds?
notes. Yes.
So what are all single bonds called? Pent, what?
15.
pentane. So this guy would be called, actually, you don't even need this, the dash. It would be called 2-bromo-pentane because you have a halide on the second carbon. You see that? Piece of cake? Are you with me, Olga?
Yes.
Okay, so let's test this out. Let's see your skills. What if I have this guy? Okay. So what am I going to do?
Throw it
What am
away and find a new one.
No, we can't throw it away and find a new one. We own it, right? We own this. We got this. Come on, Mandy, help me out. First thing I'm going to do.
I don't know. I know there's 10 of them.
So you're going to find the longest chain, right?
Yeah.
Same rule. Find the longest chain. So that's 1, that's 2, that's 3, that's 4, that's 5, 6, 7, 8, 9, and 10. So there's 10 of them, like you said. So that means our ending is going to be
Deck chain.
decane. Okay. So now tell me where the bromos are at, and the fluoros and the chloros. Where are they going to be located at?
Wow. 2.
2 bromo fluoro. Or do you have to add 2 twice?
2 bromo, and then we are going to have to say where the fluoros at, because don't we have 2 fluoros? We have one here and one here.
Oh.
So then it would be 2, 3, and then what am I going to use?
Fluoro?
Die.
Difluoro.
Difluoro.
Yep. Fluoro. And then
4 chloro.
4 chloro. Now, Mandy, I thought you said this was hard.
Oh, it is. I don't understand why you put 4 after 2.
Alphabetical. B.
Oh.
Yeah, it's not numerical. So it's alphabetical. It's B, it's C, it's F. Piece
So
of
can you
cake?
do this in reverse? Can you give us some names that we can draw?
Yeah, I could do that. I like that. But
It's a good idea.
are you going to let me introduce you to some more stuff first?
No.
No.
Well, you asked.
Okay, fine then. We can play this game. We'll make it hard then.
Hey, it wasn't me. I'm innocent.
Okay, there's the name. So, what is the longest chain?
8.
Octanol.
8. Okay, so let's see. We'll go 1, 2, 3, 4, 5, 6, 7, 8. Okay,
Isn't it supposed to be in alphabetical order?
what was that? Oh, yeah, let me fix that.
The alphabetical order. Like,
You're right.
So the one would have the hydrogen.
The hydrogen,
At the 1.
just put a hydrogen there.
Right? No, because it's ends in no. No, am I wrong? I don't know.
But is it just an hydrogen or is it
The
OH.
OH? There we go. Okay, so that would be 1. This is the first carbon. This is our second carbon. This is our third carbon. Our fourth carbon. 5th, 6th, 7, and 8. Okay, so then
Wait, it's HO, it's not OH?
it's OH, but since it's on this side, you always have the O connected to the bond. So OH and HO is the same thing, you're just flipping it. So we're saying that that's connected to your carbon.
Okay.
Okay, what else?
The BR at 3.
BR at 3. Okay, so we have a BR,
And an FL.
Mm-hmm.
an FL. I don't know what a FL is.
It's
That
a regular
flavor.
It's
What
an
was that?
F.
an F, a regular F.
F.
I gave it letters.
Ooh, we're definitely going to be putting that on the test. Okay. Was that it?
And then at 2, you have a mhm,
2 single carbons.
mhm.
Okay, piece of cake.
Kinda.
No.
You're just going to fight me on this, aren't you, Mandy? Or was that Olga?
I said kinda. She
You said
no.
kinda? Mandy said no.
Well, why isn't the dimethyl one? Why is that the 2 versus like I don't know how to explain it.
Oh, I misspelled methyl.
So like why does it look like this versus like this?
Because if it was like this, right? Because this is the carbon that it's hanging off of right here. I'm going to draw a dot. That's going to be the carbon that it's hanging off of. Okay. So if you draw it like this, that's an ethyl, 1, 2, because that's a chain. Aren't they connected to each other?
Oh, okay.
Where here, they're both coming off that carbon. They're connected to this carbon here.
Oh,
Okay.
and that's why it's di.
Yeah.
That's right. That's why it's di. 2
Okay.
versus ethyl. Does that help?
Yeah.
Okay.
Dr. Henry, I have a question.
Yep.
So on 3, you know how it's bromo and fluor? Like, is that because they're different? They're not a di.
Yeah, that's right, because they're different.
So like on 2, they're a di because they're the same.
Exactly.
Okay, I got you.
Okay. Any other questions? Concerns? Cash? Feeling good? Getting easier? Excellent. So let me give you another one. Okay, so we talked about the alkaline halides. Now we're gonna add to our list. Let's see. Let's do amines because amines are pretty easy. Right here. So amines are things that have a nitrogen. So I'll show you a couple examples of amines. Can you guys see my screen? Because it tripped out for a second. Are you guys there?
Yeah.
Yes.
Okay,
Yep.
good.
Yeah.
Okay, so amine are going to be N, R, R prime. And what does the R stand for again? Oscar?
Hydrocarbon. Oh, sorry.
Hydrocarbon.
Hydrocarbons. No, that's right. You can answer. I get worried because I think I'm losing you guys. I have to keep you on your toes. Okay, so it's like this, right? So technically you have your lone pair up here. We're drawing a complete Lewis dot structure. But then you have hydrocarbons, 3 different hydrocarbons. Or in this case, it can also be H's, right? So if I have this guy, we'll go. So this guy would be called ethyl methyl amine. What do you think this guy is going to be called?
Just ethylamine.
How many carbons are coming off of here?
1.
How many carbons coming off of here?
1.
So what do you think it's going to be called?
What would it be? 1 because 1 is the lowest. I mean, they're not.
Dimethyl.
So it would be di because we have 2 methyl groups, right? So then we call this dimethyl amine. Does that make sense, Mandy?
Yeah.
Okay. So if I have this guy, what do you think that guy's going to be called?
Triethylamine.
Right. Simple? Yeah, no, maybe?
Okay.
Let's
This
see.
be looking like drugs.
Well, if you look at some of your drugs, you'll start recognizing some of the names, and you should be able to draw them at a point, right? Okay, what about this guy? And this will be our last one for this one. Are you there? Let's see. Erica. Are you there, Erica?
Yes, I'm here.
Okay, you gonna help me out with this one?
I'm sure. So there's 1, 2, 3, 4, 5. So is that pentyl?
So you said that's
Pen-
1, 2,
Oh,
3, 4.
4. Okay. So there's 4. There's butyl, butylene.
Okay, so we have a butyl.
Yeah. Butyl. And then we have 1, 2, 3. Is that propyl?
Propyl.
And then there's methyl. Methyl.
Okay, so alphabetically, so it'd
Methyl
be
goes between
butyl.
them, right?
That's right. Butyl, methyl, propyl, amine. That's right.
Okay.
Okay, piece of cake. Good. You ready for the test then?
Oh,
No. Oh, I get an answer now from one person. Don't worry about it, Olga. You don't have to take the test, but everybody else is going to have to take it.
question. So basically what we're doing is breaking them up into parts and naming them, basically.
That's right.
Okay.
So the amine, the fact that you have a nitrogen, that has priority, right?
Mhm.
And then since these are all single chains, or even if they were double chains, amines have priority over everyone. So this is your priority scale over here. You see that over here in the red? I guess everything is in red. Huh? This guy, priority scale, right? So low guy on the priority are the alkaline halides. Then you have the alkanes. Then you have ethers. Then you have the alkynes. Then you have the alkenes. Then you have the amines. And then you have the alcohols. Okay?
Okay.
Okay.
And you said ether isn't always in that
Yeah.
spot.
Yeah, ether is kind of weird because if they're alkanes, you always end up putting the alkaline and you always put ether at the end. So it's not really, even though it's located, technically it's located below the alkanes, but it's not really below the alkanes.
Oh, okay.
Okay, it's kind of a weird one. So it's because you have so the IUPAC, there's another way of doing it, IUPAC, but IUPAC has adopted the old way as well. And so they haven't really winged themselves off of the old way, if you kind of get what I'm saying. So the old way is by putting the ether there. The IUPAC way is actually putting an alkali oxide, right? But if you look at anything that's made, everything that's made is going to be called ether. We don't really use the oxy, on it, except for oxycodone. But okay, so and like I said, this is just to give you guys a taste, and so you'll be able to recognize some of the chemicals that you'll be seeing in some of the reactions. All right, you'll get the full thing when you go to OChem. You will talk about reactions and how things are formed and all that good stuff. But for right now, we're just trying to get you guys up to naming and recognizing functional groups, right? Because if you know it has a single bond in and there's 3 attachments to that in, then you know it's a what family? What family is this guy? Are all of these guys here?
Mm.
The amine.
They're amines. Okay. Okay, so let's add on to the family, our priority list here. So we've gone over amines. Let's do some little ones that are a little more complicated.
So, how do you figure out the name based on the chemical itself? The name of the chemical, like if it's AlBr3 or something like that.
How do you figure out the name based upon the chemical?
Yeah.
So there's two things, right? So you'll have the chemical, the actual chemical name, which is always given, and then you have what you call the manufacturing name, right? You'll have two chemicals that will be exactly the same, right? But one is made by one manufacturer, so they'll call it, rhodium, and then another one will call it something else, right? I can't think of anything offhand, right? So chemically, it's the same chemical compound from each of the different manufacturers, but one gives it what we call a general name, right? So there is a chemical name that will be associated with that drug specifically, right? So like, for instance, I talked to you about oxycodone, right? So oxycodone is the chemical name, right? It has the oxy, and then the codon is a carbon-based structure with a couple of rings, okay? And because of that, because you have that chemical name, and then there's a generic name for oxycodone as well, right? Or another name. It does make it a little bit harder. But what you'll typically do, if you actually look up the manufacturing name, they will always give you the chemical name as well. So if you look it up, and so that's typically what most of us will do is we'll look up that name, and then from that you can get the IUPAC nomenclature, and then you can draw it out yourself. Does that help?
Well, kind of, but the homework has like you just have to figure out the name, and I don't understand like how. I don't know.
Well, right now, are you not figuring out the name? You're
Yeah,
able to
right
draw the
now, but
structure
I'm
based
seeing
on it.
the image, not
What
just.
was that?
I'm seeing the drawing versus the name.
Yeah, but you're gonna get, once you figure out the drawing, you can go both ways, right? Because once you're able to do from the stick figure, you're able to sit there and figure out the name, and then from the name, you should be able to figure out the stick figure, right? So for instance, you should be able to do both at this point. I'm giving you the tool so you're able to recognize what it is, and then after you recognize what it is, you should be able to put it together. Like for instance, let's see, we have let's do. Can you draw that one?
Yes, but that's not. Well, I guess that's not what the homework is showing. I don't know. Maybe I'll just go to the homework help. Never mind. Don't worry about it.
Okay, so the first thing is you also have to slow down because you're still learning as we go. I give you guys homework in advance so that you can start working on it and you can look things up. So don't get discouraged, right? You're overwhelming yourself because you're getting worked up, but we haven't got to some of the stuff as well because you're making reference to like this. Because I know exactly what I've given you for homework. right?
Yeah.
Yeah. And we're going to get there. Okay. We're not there yet. So I wanted to give you the organic chemistry first, and then I will give you what we call inorganic nomenclature, right? Inorganic IUPAC nomenclature. We're going to get there. So you're learning, right? You can't expect to know it all in one day unless you're reading ahead of me, which is fine, which is what I encourage, but you know, so don't get overwhelmed. Relax. You woke up on the wrong side of the bed today?
I didn't even want to wake up, so probably.
Do you need me to come and fluff your pillows?
Dr. Henry?
Yes.
I'm sorry, are we still doing lecture? I just got logged back in.
Sorry about that. Yes, we're still doing lectures.
Okay, sorry, I have some questions, but I'll wait till after class. Thank you.
Okay. Okay, well, we're going to be wrapping up. So this is our breaking point. So you guys remember, we've gone over, these are the priority list, right? And then I promise you, our next meeting, we'll go over the rest of them. We only have like, what, 4 or 5 more to go over. And then we'll start that classic nomenclature. So you guys will have time to finish your homework because I extended it till next week, right? You guys notice that?
Yeah.
No, I was freaking out about it.
Well, don't freak out. Okay. So, but that doesn't mean stop doing it. Continue working. Figure out what you can figure out, and then those that you can't, the rest of it'll come easy, right? And you want to start putting these in memory. The best way of putting these guys in memory is flashcards. Draw the structures, what they look like, and on the other side, put the names, right? And give yourself an example. Do the generic form, right, with the ones with the R's, and then do the ones with a very specific form. And work in groups. How many of you guys are working in groups? Wow, that many.